right, so let's start going over some of the solutions to the mock exam. The first three questions all refer to the same mechanism. And so we're asked what the role of the water molecule is in step 1, step 2, and step 3. In step 1, you're experiencing loss of a leaving group. And so the role of the water molecule is to stabilize the carbocation intermediate. This is why secondary substrates typically undergo SN1 reactions when you have a polar protic solvent. You essentially can form an ion dipole IMF in order to stabilize the forming carbocation. In step 2, the water is clearly functioning as a nucleophile. And in step 3, the water molecule is functioning as a Lewis base to deprotonate one of the hydrogens attached to the original water nucleophile. So looking back at the exam, question 1, the answer should be D. Question 2, the answer should be A. And question 3, the answer should be C. Number 4 is an interesting question. So we're going to start with an alkyl, we're going to end with an alkyl compound where we're going to start with a carboxylic acid. And we're going to add 5 carbons. So I think very quickly we can eliminate A and C because we need to make the acid chloride first. Then we need to do some chemistry, and then finally we need to acidify it. The actual best answer for this is going to be B. The pentyl lithium cuprate is a much milder form of this particular mechanism. And then as a result of the last step of the mechanism, the carbonyl actually goes away. So this is a great way of converting a carboxylic acid to an alkane. So number 4, the best answer choice is B. Moving on to number 5. Now, the best way of doing number 5 is just to draw the compound and then work backwards. So I'm just going to quickly draw this. And I think the best way of approaching this is, you know, these 2 bonds were made they now become OHs. And of course this originally was a carbonyl. And so notice that we have a 1, let's count the carbons. We have 1, 2, 3, 4 alkyl. If we look at A, we got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All those check out. However, the OHs are vicinal. That's a vicinal diol. This is geminal, so get rid of A. This only has 1. In fact, this has 2 alkyl groups. Get rid of B. C looks good. D, it's a 1,3 diol. Excuse me, it's a 1,4 diol. We want a 1,2 diol. Best answer choice will definitely be C. Be prepared to do something like this on your exam. You will not be disappointed. Okay, now we're asked which compound has the smallest HOMO-LUMO gap. It's the one that's the most conjugated. We can count all these if you wish, but it's going to be C. In C, you have 4, 5, 8, 9 that are conjugated. B is the only one that's really close. It has 7. D also has 7. A has 3. So number 6, the best answer choice, is clearly going to be C. Now let's take a look at number 7. And we want to synthesize para-bromoaniline from benzene. So we're going to start with benzene. And we're going to synthesize para-bromoaniline. I think the best sequence would be to 1 nitrate, 2 reduce, 3 acylate, 4 brominate, 5 hydrolyze. And so that is going to be answer choice D. Credited response for 7 is D. Eight is a little tricky with the language. We know that these fatty acids derive from acetyl-CoA. The question asks, they're derived from which decarboxylated metabolic intermediate? Acetyl-CoA is the decarboxylated form of pyruvate. And it is pyruvate which is the best answer. So, a little tricky on the language, just so I can keep my reputation. That's awesome. 9. Polyunsaturated lipids are always non-conjugated and they are always cis. I made a pretty big deal about this in the lecture. So if we look at arachidonic acid, which is a 20 carbon carboxylic acid, the double bonds are all cis and they're non-conjugated, which means I have allylic hydrogens that can easily be removed. And that's why these polyunsaturated lipids are so easily oxidized. So the best answer for number 9 will be D. And for number 8, it was C. Number 10. We have heavy oxygen 3-methyl-1-butanol. That's better known as isoamyl alcohol. For those of you who did lab, we did this in the banana oil synthesis. And this is heavy oxygen. And we're going to react this with acetic acid. When the ester becomes incorporated, the elements of H2O are lost in this fashion. And so the heavy oxygen becomes incorporated into the ester. And that's where the radial label will lie. So it is going to be answer choice B, the ester oxygen. And by the ester oxygen, we mean the oxygen that makes a single bond to the carbonyl carbon. And so that's answer choice C as well. All right, I think I want to pause for now. I'll do the next 10 questions, so be on the lookout for these. I'm going to try my best to do the whole exam before we meet on Tuesday.